You ever look at AI models like GPT-4 or these stunningly realistic video games and just wonder, how? How do they actually do that? Well, the secret isn't just clever software. It's a really fundamental shift in how we use our computers. And today, we're going to dive right into the world of CUDA programming, the engine that pretty much powers it all.
Right at the cutting edge, where models like GPT-4 and the next generation are being built, there's this one incredibly valuable skill: the ability to optimize these absolutely massive computational problems. It's not just about writing code anymore, it's about making that code run impossibly, unbelievably fast.
So what is their secret? Well, it all comes down to teaching computers to think in a totally new way. Instead of doing one thing after another, step by step, we're teaching machines to do thousands, even millions of things at the exact same time. First, let's unpack why this need for speed has become so critical. All right, section 1, the need for speed. Look, we live in a world where data is just exploding, and our ambitions for what we can do with it are growing even faster. The old way of computing, one thing at a time, it just can't keep up. It's hit a wall. So we've been forced to find a new approach. And that approach is called parallel computing. It's a simple but powerful idea. Imagine you have a giant, really complex task. Instead of one person chipping away at it, you hire an entire army, and each person in that army tackles one small piece all at once. The result? It's not just a little bit faster. It's a revolutionary leap in what we can even attempt to do. And you see this power everywhere. It's behind the deep learning that's changing our world, the photorealistic graphics in games, and the rendering in movies. It's used in complex scientific simulations, 3D modeling, even cryptocurrency mining. This isn't some niche thing, it's the engine driving our entire modern digital world. So what's the piece of hardware that makes this whole parallel world go round? Well, it's a component you probably already have in your computer, but you might think it's just for gaming. It's time to talk about unlocking the hidden power of the GPU. And CUDA is the key that unlocks it. See, NVIDIA created CUDA to be this kind of bridge, a platform that lets programmers speak directly to the GPU in a new way. So instead of just telling it to draw pretty pictures, they can command it to perform massive calculations for any task you can imagine. It basically transforms the GPU from a graphics specialist into a general-purpose supercomputer that's sitting right inside your machine. Now, to really get this, you have to understand that CPUs and GPUs are just built differently. Your computer's main brain, the CPU, is a specialist. It has a few incredibly powerful cores that are designed for latency, which is just a fancy way of saying they do one single task, like opening an app, as fast as humanly possible. A GPU, though, it's an army. It has thousands of simpler cores, and they are all about throughput, doing a massive number of simple things all at the same time. Let's use an analogy to make this super clear. Think of a giant jigsaw puzzle. A CPU is like one master puzzle solver who can find and place one piece with incredible speed. But a GPU is like hiring 1,000 people, giving each of them one piece of the puzzle and telling them all to place their piece at the exact same time. For problems that you can break down like that, well, the army's going to win every single time. Okay, so we know what CUDA is, and we get why it's so powerful. But where does it actually fit in the grand scheme of things? In the day-to-day world of AI development. Let's map out the AI ecosystem to see exactly where all the pieces connect. At the very top, you have what's called the framework layer. This is where you'll find tools like PyTorch and TensorFlow. These are what most data scientists and AI developers work with every day. They're high level, they're relatively easy to use, and they're great for building and training models. Then you go one step down and you hit the production layer. Here, you've got tools like TensorRT and Triton. These are for after a model is already trained. Their job is to optimize it to make it run as efficiently as possible in a real-world application, like on a server or maybe in a self-driving car. And then, right at the very bottom, at the foundation, you get to the hardware layer. This is where CUDA lives. It's the low-level platform that talks directly to the metal, to the GPU itself. And while there are alternatives, like OpenCL, CUDA is really the bedrock that a huge part of the modern AI world is built on. So now that we know where CUDA fits in, let's explore how it actually organizes all that work. How do you get thousands of tiny, independent workers to all collaborate on one big task without causing complete and utter chaos? Because that's the central challenge here, right? If you just throw 1,000 workers at a problem with no plan, you're going to have a mess. You need a system. You need a clear hierarchy to distribute the work logically.
And, well, CUDA has a pretty brilliant solution for this.
It's all about this hierarchy. At the very top, you have the grid. The grid is the entire problem. It's our whole jigsaw puzzle. That grid then gets broken down into smaller, manageable chunks called blocks. Think of these as sections of the puzzle that you'd hand out to different teams. And finally, each block is made up of individual threads. A thread is just one worker, responsible for one tiny piece of the puzzle. It's this beautiful, elegant system, grid to block to thread, that lets CUDA take a huge problem and map it perfectly across thousands of cores.
So, are you feeling inspired? I hope so. Let's wrap this up with a quick, super practical starter kit for anyone out there who wants to begin their own journey into this world of high-performance computing.
Okay, what do you need? First, hardware. An NVIDIA GPU is a must. But the good news is you can just rent one in the cloud pretty easily. For your operating system, you'll want a Linux environment, which is super simple to set up now, even on Windows, using something called WSL. Skill-wise, having a solid foundation in C++ is definitely key. That's the language of CUDA. But honestly, the most important thing? It's having the right mindset. A curiosity for shifting how you think, from step-by-step to everything all at once.
Look, the demand for parallel computing is only going to get bigger. It's powering the next wave of innovation in AI, in science, you name it. Learning how to harness this power means you're not just learning another programming model. You're really learning the language of the future. So the only question left is, are you ready to help build it?